Hi everybody, this is lesson 4.3. The title of the lesson, the fixer upper. Let's go ahead and read the specific objectives. Students will understand that they can find formulas through the internet and reference book. A variable can be used to represent an unknown. Using a formula requires knowing what each variable represents. They must know the appropriate units for length, area, and volume. Students will be able to use formulas from geometry and perform calculations that involve rates and measure to support financial decision and evaluate an expression. So if you notice, these objectives are exactly the same as the lesson that we did prior to it. So we're going to talk about more home improvements, and we'll be calculating the cost associated with that. All right, let's look at the problem situation number 1. Let's return to the home improvements being made by Chris and Liz Sanchez. This is a brick grill in the backyard that they have decided to build a concrete patio next to the grill. The patio will be 3 feet wide. Let me highlight that. So 3 feet wide right here. Oops. All right, 3 feet wide. Then also, where am I? 2 inches thick. And it's also 6 feet long. All right, that's 6 feet long. Alrighty, they will use 4-pound bags of pre-mixed concrete, and each 40-pound bag makes 0.3 cubic feet of concrete, and it costs $6.50 for that 40-pound bag. For one bag, $6.50. How much will it cost in the materials to build a patio, including a 7.5% tax? Alrighty, so let's understand what's going on over here. Let's highlight what they're trying to build. Alright, so all of this piece, this patio, just a little step to get to the grill. So it's going to look like this here. And the question is how much of a concrete we need to put. So once it solidifies, it gives us that patio. Alright, so my question to you, in order to figure this out, should we calculate the area of this region, a length of this region, or the volume of this region? Which one of the three? Make a choice. Yes, we need to calculate the volume. Volume relates to the space, how much space there that patio contains. All right, so a volume formula from geometry, which I'm sure you're familiar, but you can also look it up, equals to the length times width times height. Notice it has 3 dimensions. That will be important when we write our units. So let's go ahead and multiply. So we got 6 feet long, 3 feet wide, and 2 inches thick. All right, so I wrote this multiplication question, and now my question to you is to find a mistake. What is here that is not correct when we're writing this formula? What is not correct? I'll give you a moment. All right, so what's not correct is that this unit is in inches while everything else is in feet. In order for us to calculate whether it's an area or the volume, we want to make sure that the units match. So we want everything to be in feet. Alrighty, so in order to convert this, we're going to use a conversion factor, is that 1 foot equals to 12 inches. All right, so how do we do this? We can use a dimensional analysis and put this like this, or unit analysis, where we multiply by a fraction 1 over 12, so then inches can cancel out and give us the appropriate feet. If this is confusing to you, don't give up. You can look at this. 1 foot equals to 12 inches, correct? And we want to convert from inches back to the feet. I've showed this to you in the earlier lesson, I think the very first lesson in this chapter, where if you want to go back, by looking at this, if each foot has 12 inches, go forward is multiplying, going backward is dividing. So if you just write 2 over 12, that's what we get. So 2 inches divided by 12 will give us 1/6 of a foot. 1/6. 1/6. How does that play itself in computations? Well, it's 6 feet times 3 feet times 1/6 of a foot. When you're multiplying those numbers, let me highlight this for you. Multiplying by a fraction, 1/6, is the same thing as dividing by 6. If you don't see it, you can write it over 1 like this and multiply it across. 6 times 3 times 1 is 18. 1 times 1 times 6 is 6. All right, which equals to 3. Or if you're comfortable, you can cross simplify the 6's and still end up with the 3. Now let me ask you, what should be units of this multiplication? I'll give you a chance to answer that question. Go ahead. All right, so a foot times a foot times a foot gives us cubic foot. Here we have 3 cubic feet. How do we write this? One way to write it is to put feet with the 3 dimensions like that. Another way to write it is using abbreviation CU and then feet, cubic feet. And what that means, guys, in your mind. So imagine here, you got a foot, you got another foot. This is 2 dimension. Remember, that's the area, just like we did the population density, right? The area. Well, once we add one more dimension right here, we also add the height. So now what you're getting is you're getting a cube. It looks like a cube. That's what it's called. It's a cube. So the amount of space that it has inside is called a cubic foot. Here in this calculation, that patio will have a total of 3 cubic feet of area in its inside in terms of value. All right, guys. So the next question is, oh, we still have to calculate the cost. All right. So what do we know about the cost? Well, each bag costs $6.50, and that bag doesn't matter that it's 40 pounds, by the way. Okay, this is actually an information that's not needed here because we're not measuring this concrete in pounds. We're measuring this concrete in terms of how many cubic feet does it cover. So look, $6.50 buys you 0.3 cubic feet of concrete, the pre-mixed concrete. So that's $6.50. Another $6.50 will get you another 0.3. And then another $6.50 gives you another 0.3. You understand? So each $6.50 gives you 0.3 cubic feet of concrete. Well, you need a total of 3 cubic feet. So my question to you, how many bags is that? I'll give you a moment. All right, so you're calculating how many times the 0.3 goes into 3. Well, what do? We take 3 cubic feet and we divide it by 0.3. How many times the 0.3 goes into 3? Well, it's exactly 10 bags. You see it? You can also do this using a dimensional analysis. If you want to know how many bags to buy, well, one bag gives you 0.3 cubic feet of concrete, and you have 3 cubic feet of concrete over 1, so cubic feet cancels and you get 3 divided by 0.3, which gives you 10 bags. All right, so now in terms of cost, that thing is, I think the easiest part of this whole process. All right, because now we know that each bag is $6.50, so that means that 10 bags will cost $65. And then you add 7.5% tax. We've been doing this for the past 2 lessons, which we'll be reviewing something that we done at the beginning of the semester. So it's going to be 65 times 1.075. I'm going to continue to encourage you to use this idea that if you add the tax, you just attach it to a whole and then you multiply. You can also do it a long way, but I will continue encouraging you to use this shortcut. All right, so it's $69.88. All right, so that would be the cost of concrete. All righty, let's go to the next problem situation. A local high school is building a rectangular swimming pool for its physical education program. The pool is planned to be 6 feet 6 inches deep, 20 feet wide, and 60 feet long. As a board member of the school, you are asked to calculate the cost of chlorinating the pool. Swimming pools need chlorine to kill microorganisms in the water. The level of chlorine must be high enough to kill bacteria, but if it's too concentrated, chlorine can be painful to one's eyes. You decide to use liquid chlorine. The correct concentration of liquid chlorine is considered to be 3 ounces of liquid chlorine per every 1,000 gallons of water. To figure out how much chlorine is needed, we first need to decide how many gallons of water fill the pool, and this will depend on the pool's volume again. All right, guys, so notice in this lesson we're focusing on 3 dimensions, so we're talking about the volume. So let's make a picture of, let's say, of this pool. So we got length, we got the width, and we got the, how deep it is, just kind of depth, which is equivalent to the height. All right, so something like this. And then I can get rid of this maybe right there. All right, that's better. And let's make this invisible this way. All right, so kind of like this. That's good enough. Right there is the other dimension. So this is our little box. This is our pool. And let's write down what we got. So we have, look, it says it is 6 feet 6 inches deep, 20 feet wide, and 60 feet long. So the length is going to be here. Let's write the units feet. The width is 20. And the depth is 6 feet 6 inches. So guys, look, the 6 feet 6 inches shouldn't be used as 2 units. We should convert that into feet. So look, keep the 6 feet the way it is, and just like before, the 6 inches is 6/12 of a foot, which is exactly a half. You know that 6 inches is a half of a foot, so you can write that as 6.5. All right, so whenever you're given an inch information, just put it over 12, use a calculator, convert it into decimal, and then attach it to the whole part. So 6.5. So that's the depth, all in feet. So now we can calculate the volume. All right, so volume, just like before, length times width times depth, right here instead of height. Still, you're multiplying these 3 dimensions. So it's 60 times 20 times 6.5. All right, so use your calculator, and then we get 7,800. And what are the units again? Yes, cubic feet. All right, next, cubic feet must be converted to gallons. Use the internet to find how many gallons corresponds to 1 cubic foot. So I'm going to give you a moment to search for it, and then I'll give you the multiple choices for you to select. Okay? Alrighty, so by looking online, you found that 1 gallon equals to 7.48 cubic feet of volume. That's what 1 gallon is. All right, now using that number, guys, I want you to take this right here, 7,000 cubic feet, and I want you to convert that into gallons. And you can do it whatever way you like. But the time right now, this is, by the way, the last lesson and we do unit conversion. So I'm hoping that things are getting a little bit better. So I would like for you to do the conversion. So let me give you a moment and use this information to convert 7,800 cubic feet into gallons. Alrighty, so let's review. So there are 2 ways to do it. One is logical way where, well, 1 gallon is 7.48. So when you go this way, you multiply. And when you go backwards, you divide. I've been kind of pushing this because I know our students tend to find this method better, kind of easier for them to see. Right? If you go one way, you multiply, you go the other way, you divide. And when you know, do a schematic. So when you go away from 1, you're multiplying. When you go back to 1, you divide. So here we're going from cubic feet to gallons. That means we're going this direction. So we're going to take 7,800 and we're going to divide this by 7.48. That will give us about 1,043 gallons. All right, now if the dimensional analysis is growing on you and you liking it more, I'm not sure. I don't know. I don't see you, so I can see your eyes and see how you feel about it. But one thing I could do is to offer you the alternative. So 1 gallon is 7.48 cubic feet. I wrote the gallon in the numerator just because that's what we asked to convert. You see, this is our targeted unit. So gallon is on top, and we're going to multiply it by the number of cubic feet we got, which is 7,800 over 1, and then cubic feet cancels, and then you multiply across and you get 7,800 over 7.48, which is the same thing that we did right here, which gives us the number of gallons. All right, now how many ounces of chlorine is that? Well, we kind of got lucky, is that 3 ounces cover 1,000 gallons. Remember, it's okay, it's for the whole 1,000, so the fact that it has a little more is not a big deal. You don't want to overdo it because 3 ounces is really small, so that should be okay. So to be safe, you don't want to over concentrate your full pool. So I would leave 3 ounces as your answer. Just because it covers 1,000, we have 1,048, good enough. Alrighty. And we actually have just one more question with regards to this, and that is, taking that same pool a year later, the school organizes a diving team, and they see that the pool is too shallow to dive into, so they're deciding to deepen one end of the pool from 6 feet and 6 inches, which is 6.5 feet, to the total of 20 feet. You see, they're making it bigger. All right, and the question is now how deep, well, no, it's now telling us, okay, we're adding more volume to it, so therefore we need to recalculate how much chlorine we need, right? So we expanded the pool, and now we're going to try to make it bigger. So, I mean, they expanded it, so the volume is bigger, so now we're going to try to calculate its volume. All right, one thing, looking at this diagram, there's a little thing that's missing right here. I think it's that side, somewhat, right? So if you notice, this right here, the one that I'll highlight from here to here, this top box or whatever, this is the original pool, right? It's the original pool. And then you're adding on this kind of like a triangular region, like that. All right, so you get this triangle that's forming. It's a right triangle. All right, it has the length, and it has the depth, and then it also has the width. All right, so now let me ask you a question. Looking at this is a triangle, correct? So, and then once you add up another dimension right here, that becomes like a triangle, kind of like a prism, which is a 3-dimensional thing. So to figure out how much area, how much volume it is, well, we can look at the original one, right? This original box, which equals to what? We got it right here. It's 1,043, right? 1,000. Oh no, it's 7,800 square feet. So that's what highlighted blue, all right? So that's 7,800 square feet. We're gonna keep everything in feet because all the dimensions are in feet. Now, the area of this, not the area, but the volume of this red thing, this kind of a right triangle or prism, to find the volume of this, you're going to find the area of this triangle, all right? So do you remember the area of a triangle? Let me run a poll. I'll give you a moment. Okay, good. So the area of a triangle equals to 1/2, and it's side multiplied by another side, right? Or it is BH. Here we go. This is what you know it. You've seen in your basic geometry classes, right? You have kind of the base, you have the height, and it's 1/2. Remember, it's kind of like half of the rectangle. A triangle is half of the of a rectangle. So in this case, the area of this triangle together with the depth, not the depth, but the width. So this thing, the red thing, it gives us kind of like the volume of this triangular prism is the area of a triangle, which is 1/2, and then I'm using length as the base and depth as the height, okay? And then you multiply it also by the width, which goes, you know, to there. This is your third dimension. Notice there are 3 dimensions because we're talking about the volume. All right, so that would be that red area is going to be 1/2. Length is 60 feet. Depth is, well, look, it's 20 minus 6.5 because that was the part that was originally there. All right, so this piece, let me maybe highlight it yellow for you right here. That piece is going to be the difference between 20 and 6.5. So that would be equal to 13.5, correct? Feet. All right, and then we got the width. Well, the width right here, the width, that's still 20. It's the same as this side. All right, so if you take a calculator, you'll get 8,100 about. Well, exactly, square feet. So that's going to be the additional area. And now check this out. So you got 7,800 and you add additional 8,100 square feet to what it was before. Without doing anything, doing calculation again, converting into the gallons and then finding out how much chlorine we need. Think about the relationship between these two. All right, what would you say? All right, yes, they're about equal. So if this requires about 3 ounces of chlorine, then this should also be about 3 ounces of chlorine. Now, if you want to check this, you can go ahead and do the conversion so you can find the total volume. So the total volume is going to be 15,900 square feet. Cubic feet. I'm sorry, it's a cubic feet. All right, we're going to go ahead and then divide this into 7.48 to get the gallons. All right, let me grab my calculator. So that gives us 2,126 gallons. And as you can see, that's about twice as much as 2,000. Right? It's about, it's twice as much as 1,000 because it was before 1,000. Now it's about twice as much. So that's why we should use twice as chlorine. But if you want to go ahead and kind of use a dimensional analysis, you can say, well, 3 ounces of chlorine gives me 1,000 of gallons of water. Then 3 ounces chlorine should be sufficient. So if you do it like that, so then gallons and gallons cancels, you multiply across. Right, so you multiply this 2,126 multiplied by 3, that would be 6,378 divided by 1,000. This is in ounces because that's what's left. So that will give us about 6.4 ounces of chlorine. So that would be more precise calculation. But listen, if you use 6, that would be good enough. Because when it comes to chlorinating such a big volume of water, a little bit less would not hurt the, the whole thing. You don't want to over chlorinate the pool, but under a little bit would be okay. Alrighty, so this lesson was focusing just on another dimension. It was talking about 3D, it was talking about the volume, but the conversions are kind of similar. Alrighty, so I hope, you feel a little better about unit conversions, but this is the last lesson on it. We're not going to see it anymore. Alrighty, that's it. On that, we finish the lesson.